Good morning, class. I've started to run your experiment here, which was on the alum, the hydrated mineral. And very quickly, I wanted to bring this to your attention here because I've started to heat up the alum, and I'm kind of showing a little setup here. And looking inside that crucible, what I can see is a very rigorously boiling sample. So this alum is a hydrated mineral, which means that it contains structural water. Your task is to determine the percentage of water, part of this alum, aluminum, potassium, sulfate, as well as determine the number of moles of water. This sample kind of started as what is effectively a white powder. I did take a couple of measurements, and after I heat this sample up and remove all of the structural water, we'll take a few more measurements. We will provide that to you in the form of a data table, and then you can perform the calculations. Once more, your task is to determine the percentage of water in this hydrated mineral and to determine how many moles of water. You can kind of see that the sample is kind of slowing down, and as more and more water is removed, it is becoming, well, more anhydrous. So I'm going to let this run for a few more moments, and then I'll take a few measurements, and then you can perform the calculation portion. I did have a lid. I did remove the lid so that you guys can see the sample, but typically this is run best with the lid, because you can kind of tell, if you kind of look at the walls of the crucible, you see how it kind of appears that part of the alum, the aluminum potassium sulfate, is starting to almost jump out of the crucible. I wonder if that's going to affect your data at all. All right, guys.